those are the ways by which we know what's occurring. But from your standpoint, what you can do then is based on this here, and say you were at this location right here, you know for a fact, if that was, in fact, let's put ourselves just a little bit east of here. So you can see this is approaching you here. You can see the bright colors just west of you approaching. You can anticipate that there's that potential that winds may reach 60 to 70 miles an hour at your location when this line moves on through. And again, if the winds get up strong enough, we'd like to hear from you. If you get some damage, we'd like to hear from you from that perspective as well. So there's the leading edge, and right where that white line is at, that's where the shelf cloud would be. And so if you were at this position here in Rushville right now, looking out to your west, you'd see a black sky and this low-hanging cloud that's out ahead of it. And not long after that, you'd have very strong wind, somewhere upwards close to 60 miles an hour, looks like we'll be passing towards the Rushville area. And in fact, storm spotters reported a 66 mile an hour wind gust, so pretty close to what the radar was estimating it should be. And also, we had a semi that was blown off of US 52 just west of Rushville. Let's take another look here, a different storm. The radar is located to the lower right in each of these images here. And you can see the bow-shaped configuration and the reflectivity data on the left-hand side, the data you're normally used to looking at. And the velocity data over on the right-hand side is very easy to see exactly where the strongest winds are at, where the brightest greens are. Now in this case here, this squall line is approaching the radar. So remember, green is inbound towards the radar, red is outbound away from the radar. So in this case here, it's the bright greens as it's approaching the radar site. And the folks in this town here are in the path of the strongest straight line winds. Let me advance this one step further because there's some features along the leading edge of this squall line that I want to point out. If you'll notice where these white arrows are pointing, C2, C5, C4, C3, but at each one of those locations, can you see how the shades of green are just a little bit brighter at those spots relative to either side of them? And there's actually an associated brighter red with that bright green. What those are indications of is that there is an enhanced circulation that's occurring at each one of those locations. That enhanced circulation will translate to one of a couple different things. One, it will translate to enhanced straight line wind damage. In other words, the winds at those points will be a lot stronger than either side of that. Or it may translate to a small tornado occurring at this location. Either way, you might be seeing wind speeds of 80, 90, 100 miles an hour with that feature, whether it be straight line, whether it be tornadic. It's just a matter of how the debris is thrown around. So these are features you can watch for. And again, in this case here, where's the shelf cloud? It's along the boundary between the red and the green. Remember, the green is outflowing, so that's the location of where that shelf cloud in the sky would be. This is one that occurred across central Indiana a couple years ago. In fact, you can see there, January of 08, it hit all of us, including down here. And this small segment that was right here just to the northwest of Indianapolis. Let me advance one here, and you can kind of see just a little bit brighter green kind of associated with this brighter area of red that produced some strong straight line wind damage when it went through Avon, west of Indianapolis. It also produced a small tornado on the northwest side of Indianapolis right off the interstate, and it also produced some straight line wind damage in the town of Speedway just north of the airport. And so again, here was a case where the squall line produced both straight line wind damage and also a tornado. And it came from this area of enhanced green, or bright green, bright red couplet, where there was enhanced rotation that was taking place. Here we have storm spotters that are videoing some of the damage that can result from straight line winds.
Oh, wow, look at this tree's going. Whoa! These trees are just falling apart.
So there you saw winds probably right about 60 miles an hour. This next one, a Canadian downburst, a little bit stronger. Now right now the winds are probably pretty close to 60 miles an hour, but in just a moment here, they're going to really pick up. There you go. And there you have that extreme gust, probably in excess of 80. And as you saw, the force was literally crumbling around them. When that was all said and done, just off the side of this cabin there, literally it laid down a large forested area about the size of a football field. Straight line winds, they can be very strong, they can be very damaging. Here we have some examples of what typically happens with straight line winds. Those winds are blowing essentially the same direction that the line is moving, and what you'll tend to find is a lot of your damage is aligned in the same direction in which the winds were blowing and the storm line was moving. As you can see by all these trees here, how they're all kind of lying down facing the same direction. That January 08, the squall line that moved through Indianapolis, this is a house that was in Avon. The garage door that was over here was blown in by 100-mile-an-hour winds, and it literally blew out the side of this garage. So, as you can see, straight line winds can have very significant damage with them. I also made mention tornadoes are possible embedded within squall lines. Here's an example of one which has taken place. And from a storm spotter's standpoint, you literally just have to be in the right place at the right time, or wrong place at the wrong time, depending on how you look at it. But they're small and they're short-lived, but yet you can see the damage that they can cause. So they're a tough thing to spot for spotters, and they're just as tough for us to see on radar. Because these circulations are so small, oftentimes there may be no signature whatsoever on radar. Or at other times there might be a signature there, but that signature may be only there one single instant in time, and it's not there in the image before, and it's not there in the image after. So they can be really tough to warn on. So with regard to squall lines, again, this is our main source of wind damage in central Indiana. And the main feature associated with is the shelf cloud. As you see in these two examples here, the one on the top, rain immediately behind it. The one on the bottom, the rain delayed a little bit. In both cases, they represent downdrafting and outflowing air. And they will be moving away from the precipitation area. And keep in mind those possible locations for tornado development. So you want to be using your Doppler data so that you have an idea of how strong the winds are and whether or not there might be small circulations that are along that lead edge that might provide enhanced damage or perhaps a tiny tornado. Well, let's now move to the supercell thunderstorm. And actually, before I do, does anybody have any questions with regard to the squall line storms? Yes?
Is that sunlight between the squall line and, between the shelf cloud and the storm, is that significant and something you need to know about, or any indication of something you need to, that we should be concerned about?
No, not really. Just that you're aware of what's taking place there, that you can still anticipate the wind shift will take place, but you'll know that the rain might be delayed. In each one of these cases here, you're looking at a small tiny, the picture is a tiny portion of the sky you're looking at. So you will likely see that smooth bluish gray down to the ground somewhere behind it. And except in those cases where that shelf cloud might have gone so far ahead that there may not even be any rain left behind, the storm simply has died out, which is a possibility. Yes, Carl?
The ham radio operator that's watching radar,
Okay?
what should he be telling the ham radio operator that's in the field?
Look out. And I'm not trying to be funny about that, but you're right. Everybody's going to get slammed by that line. There's no question. What you can do, though, is by using that Doppler velocity data, you can let those folks know who is directly in the path of the strongest straight line wind. And if you happen to have any storm spotters that might be somewhere close to where those bright spots along the lead edge might be coming right across their location, you let them know, hey, be aware of the possibility of a brief tornado that will come with that.
Be aware of the possibility.
Yeah.
Okay.
Yeah.
Not there is a tornado.
Right.
Okay.